Hello, welcome to Enlightning, where today we're going to learn about the CNCF project KubeArmor and learn about Runtime Security, which I'm really excited about because I know so much nothing. So we're here with Barun Acharya, who's going to teach us something. At the end of this 2-hour period, we're all going to know at least 3 things. Barun promised, right? Barun, welcome. Thank you so much for sharing your time and expertise with us today. And tell us about yourself, please.
Hey everyone, I'm glad to be here. I'm Barun Acharya and I work as a software engineer at AquaMonitor. I am also one of the maintainers of the project that we will be talking about today, KubeArmor. I have been associated with open source past 3-4 years and love the community, love the folks in open source. I've been associated with programs like Google Summer of Code, Linux Foundation mentorship, love to mentor, and I've had a great time being a mentee as well. That's all from
That's
me. I'm
that's
totally very excited
amazing.
to be here.
Speaking of the kind open source community, Kumar's here. Hello, Kumar. Thank you so much. Um, uh, well, what's amazing about what you just told me about being a maintainer on a CNCF open source project and having done as much as you have? Uh, During pre-show, you told me you just graduated last month from college.
I did. I finished my bachelor's just last month.
That's amazing. Congratulations.
Thank you.
So, yeah, yeah. I've had people reach out to me. It's getting more common for people to DM me and ask like, how do I get involved in open source? And I do link them to the Linux mentorship program. And tell me more about your experience with that.
I've been associated with Linux mentorship mostly as a mentor. I
Okay.
started with a similar program by Google called Google Summer of Code, which
Okay.
was my break into open source. I've been
Yeah.
trying to contribute in general around like more than 3 or 4 years back, but Google Summer of Code was the break I got, and that's how I got deeper into open source. And now here I am, maintainer of Kubon.
And here you are, maintainer of KubeArmor. So, those who are tuned in already, let us know, please, what is your current container runtime security strategy? I didn't even, before I started looking into KubeArmor in preparation for the show, I didn't even know such a thing was needed. Like, I'm doing a series on policy tools, and this came up as a policy tool, which I see how it is, but I only knew about like cluster wide policy tool and not like runtime policy tool. So I'm interested to dig in. I'm trying not to get to the meat of it. Sometimes when I get excited, I want to talk tech before I've moved behind the light board, and I feel myself doing that now. So just to give people just a couple minutes to arrive, let's talk some soft skills, some soft stuff. Like what are some of your hobbies?
Hobbies. I mostly love to watch and read anime and manga. Occasionally, I do play keyboard a little bit, but I only know so much about it. But I do try
Nice.
to work on it in my free time.
Cool. I play just a little bit of keyboard too. And similarly, I built out some pretty bad songs in my free time at home alone though. But what's the difference between manga and anime?
Anime is mostly like what how you have visual representation in a video form, and manga is like how you read comics. Comics is
Okay.
comics is manga, and like I will be hated for this, but cartoon is equivalent to anime.
So saying the word cartoon is going to get you in trouble with some folks.
That's easiest
Kumar's
way to explain though.
Yeah, yeah. It's just someone as green as me. I like it. I as part of doing enlightening, I've definitely figured out that sometimes you just sometimes you need to say the easy thing instead of the perfectly correct thing, because the perfectly correct thing, if you want to try to encompass every single edge case into your statement, then you can only talk about your technology in a really complicated way. So sometimes you just need to be like, okay, we're going to talk about it as though you're using it for a very vanilla use case, just so you can wrap your head around what it is. And then later you can get into all the nitty gritty. Kumar endorses you. Barun, he says you're going to love Barun explainers. I'm pretty excited. He already did a great job of explaining anime and manga. Manga? Oh, I've already messed it up. But let's get behind the light board. So, will you dig in a little bit more on your career path and especially how did you get that big break at Google? Like, what do you think you did differently to get chosen? Or tell us more about how you became a maintainer of a CNCF project at 1 month out of college.
Sure. So I'll start with like I had just entered college and was exploring all the technical communities out there, technical and cultural communities both. And then what like one of them was open source developers community, which is in the which resides in and around our university called JAIT. So I started there, started attending. It was a local chapter. People came in every week, talked about random things they worked upon, random projects they built, but all in the spirit of open source.
Ah,
So I started
yeah.
attending them, uh, learned a lot, met with few folks who had been associated with these mentorship programs. They told me about it, and since then like I've been trying to contribute to random projects around there which interested me. I started with JavaScript mostly. In the JavaScript ecosystem I contributed to a couple of projects. In there was a specific project called Public Labs, which is a non-profit organization which help folks for environmental environmental research and stuff. So
Cool.
I helped them with their website. So they didn't have a testing framework back then. So I was working around the testing framework, built and set up the framework, automated a few things, and then the opportunity came about how they were participating in a program called Google Summer of Code. Being so like we usually have summers free in our university, so I thought I should just sign up to that. Created so they
Nice.
had a few problem statements, created a proposal for that, and I was selected. It was a fun 3 months working on the project, learned a lot, networked a lot, and around that time I joined Aquinox was a new startup which was handling cloud security. So
Mm-hmm.
I interviewed, got in, and KubeArmor just started back then. It wasn't even under CNCF back then.
Okay.
So
How
I
long ago was this?
joined. It was roughly 2 years back.
Okay.
It wasn't associated with CNCF. We were like I joined and we were discussing about how we should get into CNCF Sandbox, and like this is we will talk about it, but yes, it's an interesting project, and we definitely have we serve use cases. So setup I initially was responsible for all the like CNCF Sandbox has some checklist like that we need to cover, like how the project should have automated things, linters and things like that, like how a new contributor could contribute and still have all the checklist have completed. So I worked upon that, and by the time like I was 3 or 4 months into Aquinox, and we had CNCA, like we were a CNCF Sandbox project.
Amazing. That's so cool. So when you made a proposal and you got accepted to the Google Summer of Code, then you got to build out the thing that you proposed. Is that how that works? Yeah.
Yes, like
Cool.
you basically this give you problem statements. You need
Mm-hmm.
to give a design document around how you are going to work on this problem statement for 2 or 3 months,
Mm-hmm.
and it depends. Like you could extend it up to 6 months, but that there's a set. The pattern is around 3 months only. You
And then
it depends from project to project, but you are maybe supposed to give the timeline as well, like in which week or in which month, what are your targets and things like that. So like you have a proper design document for what you are going to
okay.
work, and that's how you so like even though design documents are like you may stray a lot from the project you initially planned upon, because you never know what can happen, what an unknown bug can come into the picture
That's
and it totally
a
deviates the
great
project.
it's a great life lesson. When people are
I
like,
had
"What's your
mine.
5-year plan?" Yeah, I'd uh-huh.
I was supposed to integrate with Google Sheets, so like Google Sheets API, and I
Mhm.
was working with version 3 of the API, and I had
Mhm.
completed my project, and Google deprecated the V3 API.
Yeah.
Then I had to redo things for V4 API and things like that. But yes, definitely a life lesson.
Yeah, planning it can be silly. Like people say, "What's your 5-year plan?" Like 5 years ago, I was like a server at a restaurant. Like I hadn't even touched my first line of code in tech yet. Like I couldn't have possibly dreamed like this moment right now. So how could I make a plan for it? Yeah. Anyway, let's get down to business, Varun. Um, you said you've watched a few episodes now, so maybe perhaps you know the way I love to start once I'm behind the slide board is give me some context about what the world was like before KubeArmor existed. What problem was out there that caused your technology to need to be created?
So, like, I will start around how runtime security comes into the picture and why CubeArmor was born. Like,
Ah, so before we get into why KubeArmor, do you want to say a little bit more about what runtime security even is?
yes, yes, yeah, yeah.
Okay,
So, like,
I'm all
how
for that. Okay.
so what happens is like we have in our like ecosystem, we already do scan our workloads, we do scan our there are in like infrastructure in place to scan things. Like we know that this is not your declared you have declaratively managed your infrastructure, so you scan those files and know that no, this is not configured correctly, this might be the vulnerability. Maybe like recently nginx had a vulnerability, so beforehand you know that nginx version 1.2 has some
Mm-hmm.
vulnerability. So if some
Mm-hmm.
application is using nginx 1.2, the
Mm-hmm.
scanning ecosystem will alert you that it has a
Mm-hmm.
vulnerability, please move to 1.3 or something like that. So
Mm-hmm.
that's how static scanning works.
Uh-huh.
But we never know what when a new vulnerability can pop up.
Mm-hmm.
Most like an important lesson was by the log4j attack which happened.
Oh,
Suddenly
yes.
there was a vulnerability in, I guess, one of the in log4j, and people had to work over Christmas to fix that. So
Uh-huh.
that is something which happened. So we cannot predict when a vulnerability like that can pop up. So we call these vulnerabilities 0 days. Or what if there's a vulnerability but no one knows? There are attackers out there which target specific workloads and try to attempt an attack on it. So the concept of there are a lot of unknowns out there which we
Uh-huh.
cannot pre-scan towards. That's where runtime security comes into the picture. We need visibility into what's happening live as your workloads are running, and we
Uh-huh.
need to profile them and understand that like, oh, maybe the Java application was only supposed to access this and this file, but now since the Java application is accessing the XYZ file, that's that's not something which should have happened. So we know that something wrong is happening. So this we
Okay.
only got to know because we were like we had view into the runtime ecosystem.
So image scanning is how right now it's the industry standard for how you know you're running an image that doesn't have any vulnerabilities. But the vulnerabilities that are being scanned for are the ones that people know about. It's possible that there are vulnerabilities that are yet unknown. So I feel like you gave two examples of vulnerabilities that you can't scan for. So so you can't scan for unknown vulnerabilities, right? And then did you say there's a second one?
Like attacks that are happening at runtime, like maybe privilege escalation attempts, which like once these
Okay.
vulnerabilities are exploited, the next step is like how they are being
Uh-huh.
exploited. So those attempts you cannot account for through static scanning, right?
Ah,
Like when a live
okay.
attack is happening.
Okay. So there are security issues you can't scan for.
Yeah, that that's better.
And so one would be unknown vulnerabilities or an attacker taking advantage of a vulnerability. Yeah?
Exactly.
Of a runtime vulnerability. Got it.
So I was like talking like how we can, but since these are unknowns, we cannot really predict about them. So what we
Yeah.
can predict is how our applications are working today. Suppose there's an application ABC which is only supposed to access file 1, 2, and 3. But now
Uh-huh.
someday it tries to access the fourth file, which it is never
Uh-huh.
supposed to access. So when we get that event, like, oh, fourth file was accessed, we know that something wrong is happening in our system. And
Okay.
that's how we know that there's a security concern. And ideally, we should set up like set up ecosystem such that like the fourth file should never be accessible to the ABC application.
Uh-huh.
That's where KubeArmor comes into the picture. A little spoiler alert, but yes, like you you get the context that okay, the fourth file was now accessed, so
Mm-hmm.
I know that there's something wrong in my system now, and that's how I
Mm-hmm.
know that that's what the runtime security is all about: finding what's not supposed to happen, what's happening in your application, and trying to profile and understand like what should be happening and what should not be.
So the question is, how do we secure against unknown unknowns at runtime?
Yeah, unknown unknowns. Yeah.
Um, Specifically at runtime though, yeah? Yeah.
Yes, yes.
And that is basically that's runtime security. Solving this is what runtime security is. Yeah.
Solving this is about how runtime security works. Yes.
So if you had to write a
If would
definition, yeah.
so like runtime security would involve, I guess, three things.
Mm-hmm.
Three things in general, like how you need to monitor your application, like monitor what's all happening.
Mm-hmm.
Second would be alerting you when something which is not supposed to happen
Interesting.
happens.
Mm-hmm.
Monitoring, alerting, and third is enforcing. So like block that, like take prevention or preventing would be a better word. So monitoring, alerting, and preventing it at all, so further damage does not happen. So like that's what how I try to talk about runtime security. You first monitor what's all happening. You need to
Uh-huh.
receive alerts about what shouldn't have happened, and then preventing what shouldn't have happened.
So how do you alert I guess you kind of gave an example on what shouldn't happen if you don't quite know what shouldn't happen, because you say this application gets access to these 3 files, but you don't know all the different things that someone might try to do outside of that rule. So that's why you're alerting on any deviation in a rule that you've set. Yeah.
Like
Yeah.
it's, if you want to, like, if we go deeper, like how it comes into the picture in today's like cloud native infrastructure, the
Uh-huh.
like what's the key element to running our applications? It's containers, right?
Uh-huh. Yeah.
So what we try to do is, like, we try to set up things around our container, make, like, add a wall around our container, and such that, like, no other attacks can penetrate the wall. But
Okay.
what if, but we never know that what if the attacker is already inside your container
Uh-huh.
and it starts to parallelly shift into other things. So we need to understand that containers are not black box. There are
Yeah.
entities inside the containers which we need to understand. And that's where
Uh-huh.
this monitoring and alerting will come into the picture. Like, what are the entities running inside our containers? How should we, like, how should we profile them? How should we, so, like, how things generally work is, you, before running it in production, you have your staging environment or development environment, right? So, like, you
Mm-hmm.
profile your workloads and containers in those environment, understand what all things are supposed to happen. So,
Mm-hmm.
for an example, inside containers try to access outside network. Like, maybe it's for communicating with other containers, or just maybe you are trying to access network. Like, maybe you're just trying to access google.com from inside your container.
Mm-hmm.
So we now know that, like, containers from inside, only a single binary would be, maybe a curl or a curl binary would be trying to access the google.com, or your application should only be accessing other application containers. So
Mm-hmm.
other binaries should, so the moment, like, suppose, just name the binary malicious. Now malicious binary tries to access google.com, or malicious
Uh-huh.
binary tries to access the other content, suppose container wire.
Uh-huh.
That's where we know that, like, okay, so this process shouldn't have access that, and
Uh-huh.
this access never happened in the staging environment, but it's happening in our production environment today.
Okay.
So we know that something is wrong. This we only know that something is, like, so monitoring is that curl is trying to access google.com, we get a monitor that, okay, curl tried to access it, malicious tried to access google.com. But now the alerting ecosystem is that malicious tried to tried to access google.com, which is
Uh-huh.
not right,
Yeah.
because it's a new thing which was not in our earlier ecosystem, earlier environment.
So I think the way that I want to capture this is maybe as a cluster administrator, maybe a linear experience of what you're how you're learning what rules to write and then what we expect those rules to do. So like you said, there's first like a discovery phase where you're in development and you're profiling your application.
Right.
Yeah. Does that sound like an okay way to capture this story? Am I for
Yeah,
you?
like,
Or do you have a
yes,
yeah.
yes. No, that's fine. That's the way we should go. Yeah.
Okay.
So, like,
So I'm gonna make this a series of steps.
hmm,
That's gonna be like how to define and implement runtime security. Does that sound right?
sure.
Okay. In your system. Okay. So the first step is when your application's running in a staging environment, you profile the application, right?
Yes, right.
So what would be an example? Like, I like your idea of giving an example thread through all of this. We have some nice comments too. We have a Yushu did a laugh. Who knows way back when what we were talking about that. But thank you for And then we have Rurak. Sorry, I can't see your name. Rudakash. Thank you so much for coming, and thanks for the nice comment.
So for the example, I think let's just say that let's like, since we are talking about cloud security, let's go like, we know about service account tokens, right, which are mounted inside Kubernetes pods or any object in Kubernetes. So service account token is generally needed when you try to access the Kube API server, right? Like any Kubernetes, when your application needs to communicate with Kubernetes, it accesses service account token. So suppose,
I want this to be an example that we can thread through the whole story. So if it makes sense to use your example where one application is trying to access another application instead of only accessing google.com or whatever.
Yeah,
or I trust you.
I think this would be fine, like, because application more often tend to access Kubernetes API as well, so it would be practical as well as easier to explain, not naming things A, B, C, D.
Yes. Oh, I love it. Okay, so what's our example, please?
So suppose we have your application. Let's name it app. App tries to access the Kubernetes API.
So it does access Kube API because that's what it's supposed to do, right?
Yes, it's supposed to do, yes.
With service account token.
With service account token, yes. So in general, this, like, you need visibility into what all happens when this particular specific step happens. The app is executed, app tries to access service account token, and at the end of the day, it sends a network call to Kubernetes API. So let's define it in these three formats. Like, the execution of app happens. App tries to access service account token. So, like, this is an example of how your profiling output could be.
Okay.
And app finally communicates with the through network. App networks with Kube API.
I like communicates, even though it's long. Talks.
Talks to Kube API. Yeah, best. Hey, I have the passcode. Now please give me the access.
Yes. High five. All right.
So you know now that, okay, your application is only supposed to do these three things. And you have profiled your application. And you only could profile it because you had monitoring enabled. Or else how else would you know what your application is doing? So monitoring comes into the picture, that we know that this is only these all things are happening now.
Excellent.
Now let's move our app to production.
Will you repeat that, please? You had some static.
So like, let's now move our application to the production environment.
Okay. Okay.
So now we have this monitoring enabled in production environment as well.
Mm-hmm.
So these three things are obviously happening in production environment as well. But
Mm-hmm.
now maybe the D and E steps could be app tries to access Google, like maybe say VMware.com, since we are on Enlightning. App tries to
Okay.
access VMware.com, or app2 tries to access service account token. After all, after
Okay. So we expect this behavior that we defined above, right?
yes,
Okay.
but now other than this defined behavior, we have
Mm-hmm.
maybe execution of app2.
Okay.
Maybe let's name it. Maybe you can just directly name it like execution of unknown. It's an unknown, right? Some unknown execution happened in your
Uh,
production environment, and
uh-huh.
that is something we monitored. Like, okay, an execution of unknown happened, and unknown tried to access service account token as well.
Okay.
So what will happen is that since we had already profiled and set up that okay, only these three things should have happened. As soon as
Mm-hmm.
this happened, the alerting thing comes into the picture. Okay, unknown, there was an unknown execution, or unknown
Mm-hmm.
tried to access something which is not supposed to happen. So as a security administrator, you get the alert that okay, this was not supposed to happen, and this happened.
Okay. So then because we're monitoring, we see that happen and then it causes alerting.
Exactly.
Yeah?
Right. So we covered monitoring and alerting. But
Mm-hmm.
since an unknown execution happened, it should never have happened, right? That's how we can secure our workloads, that no unknown
Mm-hmm.
execution happens, and we can prevent any unknown vulnerability. So that's where preventing comes into the picture. And there
Uh-huh.
are a couple of ways to go about it.
Uh-huh.
On a higher level, there are two ways to go about it. So one is preventing it as soon as it happened. Like, okay, we know that unknown executed, and unknown is prevented right there and there before, and we let the security admin know that okay, unknown was prevented. Or the other thing is, let's type this first. Like, what if okay, you received the alert, now the security admin goes ahead and sees that okay, unknown is being executed, and I manually go ahead and kill it. Okay, unknown shouldn't have happened, I kill it
Mm-hmm.
and kill the unknown binary. So that's what we call asynchronous enforcement. So like this entire life cycle happens, you get the alert, then as a security administrator, or you have some automated work thing in picture which goes ahead and okay, unknown executed, I kill the unknown thing. This strategy is called asynchronous enforcement.
Uh,
Security events prevented. What's prevented? Attack prevented? What's
Attack
called
event.
attack? And the prevention can happen either automated or manually.
But
Yeah?
important point to note is that it only happens after the alert was sent out.
Okay.
So there's a lag in the event which can be further exploited.
Prevention happens after alert. All right.
The second strategy is inline enforcement. What we call inline enforcement is like as soon the one who is responsible for the alerting mechanism is also responsible for preventing your attack. Like, okay, it got to know that alert, and the unknown thing is trying execution, but the trying attempt failed because the engine there prevented it from executing. Prevention happens with the alert, or yeah, before alert. No, it's at the same time. I'm not sure what would the right time.
Excellent. Fuel Snobbles here. Hello, Fuel Snobble. Thank you so much for coming by. What do you do, Fuel Snobble, for runtime security? Fuel Snobble comes here regularly. He's a buddy. Fuel Snobble says, security, we run Kubernetes on Linux, so it's secure. We're learning all the ways it's not, Fuel Snobble.
We are diving deeper into it today.
He's Varun's teaching me what runtime security even is because I'm unfamiliar. I'm gonna take this off because we know. Yeah, so there are a couple strategies for prevention. One is to wait till it happens and then either automatically or manually like kill the process or whatever, but there is some time where it is actually happened. Or strategy 2 is called inline enforcement, and then that's where the attack tries to happen, but it fails before it can actually happen.
Exactly. Yes.
Oh,
So
Scott Rosenberg's here too. Sorry to interrupt. What were you saying, please, Varun?
no, like I think that's how that's the entire definition about how runtime security in general works.
That's wonderful. So with that, do you want to talk about like before KubeArmor, or do you want to just jump into what KubeArmor is?
No, let's dive into like how what's the current, like how this is like. So before that, like I just wanted to say like asynchronous. So since we explored both async enforcement and inline enforcement, there are ways to deal with both of them before KubeArmor. So just let's dive into that and what may be potential issues with that and how KubeArmor came into the picture. So we can go that way.
So we're going to talk about before KubeArmor how people were dealing with each of these types of prevention.
Exactly. Yes.
Okay.
So for so in Kubernetes, you can enable, how do we say it? So there's a thing called pod security context in Kubernetes
Okay.
where you define all the security primitives that are supported by Kubernetes. You can define in your YAML file, YAML deployments, how you can secure them. Some specific things which come under pod security context are you define capabilities, you define seccom profiles, and you define AquaMonitor profiles. So we will dive into what they are specifically. But
Let me ask you just a logistical question. Should I use this little space for before KubeArmor, or do you want me to I'm afraid I want to leave enough space for KubeArmor itself, where you're not only just teaching me about runtime security, and then it's like, okay, here's KubeArmor real quick. But maybe that's your vision.
I think that should be enough. Like we will.
This little space will be enough?
Yes, yeah.
Okay. So folks use the pod security context Kubernetes object.
So in general, what pod security context accepts is you define a set of rules in pod security context.
Okay.
In different formats, it has a lot of things which we will cover later. But the thing is that you define profiles and rules in pod security context. Issue there is that how do you come to know about what profile? So like you can set up the prevention here, but you never know what happened. So you don't have the monitoring and alerting mechanism.
Okay. So no monitoring, no alerting.
Let's just mention no monitoring. You can define alerting in a way which has issues, but to be accurate, it's only no more. Like since you don't have monitoring, you never know what exactly happened, and you cannot create the set of rules. You are just guessing and trying to do things.
How can you alert with no? Okay, I put inferior alerting just so you could. We have
so what happens is under the hood, pod security context uses some Linux primitives which have their own alerting mechanism when they deny things. So you have that, but you never have the context. Like, okay, in which container exactly this happened? I never know.
Okay.
I just know that okay, something was denied. So inferior alerting, yes, is the right would be the right. And other thing would be like you can set up. So there are tools out there which can help you with monitoring and alerting, but then they don't have the prevention part. Tools like Falco is one of them. There's Tracy. There are other tools as well which help you. Some example of tools are Falco and Tracy, or you can just like people have set up tools made on their own with eBPF as well to set up monitoring.
You said Tracy? How do you spell that, please?
TRACEE.
I would have never guessed that.
This Falco, yeah. So they have the rule engine, they have monitoring, they have alerting, but they don't they don't help prevent things. So what could have happened is people who use these tools mostly rely on asynchronous enforcement. That okay, I got the alert that okay, things happened, but now I'm trying to identify how should I stop. So that's the entire picture for like what happened before KubeArmor.
Okay, excellent. And Phil Snobble has a joke. What do we do about bug bounties? Do those count as prevention? Just pay them off? That counts. They go away, right? Yeah. All right.
Bug bounties are like it's just that like how I mentioned that an attacker can take advantage of vulnerability, but bug bounties are generally that okay, the attacker was kind enough to not take advantage and help you out there.
We have 3 types of prevention: asynchronous enforcement, inline enforcement, and just paying off your attacker.
Exactly.
Yeah. Cool. So is it now time to say what KubeArmor is?
Yes. So like KubeArmor is a cloud native runtime security engine, which is responsible for the 3 things I mentioned: monitoring, alerting, and preventing vulnerabilities in your workload.
cloud native runtime security engine. That, did you say that is responsible for?
Yeah, that helps you with handling these three things that I mentioned.
Okay. Handling, monitoring. Monitoring your system. Alerting on anomalies.
Anomalies, yes. I've been trying to remember that word. I was not able to.
And preventing. Is attacks the right word? Security issues, attacks?
Yeah, security issues. Yeah.
Security issues. And then we have some chat activity. Scott says they mostly use Prisma and Aqua, but KubeArmor is very interesting, especially since it's open source. Agreed.
Yeah, like what I talked about, like Tracy comes under is a project by Aqua only, and yes, it's mostly as Fuel Snabel mentioned, it's mostly monitoring, and it also covers alerting. But yes, it does not handle prevention.
Yeah. Oh, wait. So perhaps is the name of a technology?
No, like so
No.
perhaps
Oh.
the what Scott mentioned.
Got it.
Is so like
Cool.
Prisma and Aqua, what offer comes under yes monitor. So they are also handling runtime security, but they only help you with monitoring and alerting about the malicious events that could happen.
Cool. See, I I think we're doing well. I think this is actually really great, but I know so little that I can't properly moderate the comments because I don't understand so much. But it's great. That's why we're here. Okay.
So yes, we introduced KubeArmor now.
We did.
So we can maybe talk about some features of KubeArmor, like where it is used, how it helps out with the aspects which we talked about. So KubeArmor help like KubeArmor. So like in general, we talk about Kubernetes, but KubeArmor is not limited to Kubernetes. You can directly protect containerized workloads. We have seen a lot of interest from Edge, and so like what happens is in general, Kubernetes runs inside by in a managed provider like Google Kubernetes Engine or AWS EKS. So, and they do a pretty good job of providing a secure host. But in edge workloads, which is distributed around the world and being orchestrated, they don't have the same level of security, and we receive a lot of attention there, a lot of attention KubeArmor from them. So yes, KubeArmor is not limited to Kubernetes. You can protect any unorchestrated workload as well.
Cool.
So what KubeArmor does is KubeArmor helps you. So like we talked about like how there's no monitoring and inferior alerting. To tackle that, KubeArmor sends you on a high level, sends you 4 types of events. There's process, there's file, there's network, there's capability, there's any system execution engine.
KubeArmor sends the cluster administrator 4 types of events, or just emits 4 types of events? No, probably not to anyone, right?
Emits.
Okay, yeah. Okay. before I wrote the. All right.
So like how we were talking about what like under runtime security, we talked about like how we define the expected behavior of an app. So we talked about execution of an app. So that's a process. That's a process event. The operation
Process
of
event.
event is process. Yeah. Then the application tried to access service account token, and service account token in general is stored in a file inside a volume mount in Kubernetes. So it's a file event.
Okay, I'm sorry, you're a little bit ahead of me. I just forgot how to spell the word process for a second, and then also I want to write down. So a process event. So for example, an execution of an app, right?
Yeah.
Okay, and then you said a file event?
Yeah. So file event could be app accessing a particular file. In our case, service account token in Kubernetes is stored inside a file. So application tried to access that.
Great. Cool.
And the third type of event is network events. So essentially KubeAPI server lives outside the container, right? So it's a network call to them. So application tried to access the Kubernetes API or any URL in general, or any other applicant needs to communicate with other applications. So all of this happens over network.
And so it tries to access a particular thing over the network? Or it
Like
just shouldn't use, yeah.
Like essentially it's an IP address, but tries to access let's just since it's an example, tries to access the Kubernetes API endpoint.
Okay. But okay, so a particular thing.
Okay.
I like a particular thing.
A particular, yeah.
Over the network.
Exactly.
Okay.
And fourth type of event is any system, let's call it system event. Like it could be maybe your application is trying to access privileged things. So it requires the sysadmin capability. Or so there are events around like in general system call events. So an example could be application tries to access specific capability.
Is the app making the system call?
Yes.
Okay. Any system call or a particular system call? An
It's a
unauthorized?
configurable. It's a configurable thing. Like KubeArmor just emits the event. Now you configure what type of events you want. You can configure them.
Okay. Oh, got it. Cool.
Good. So now since we have these events, we use these events to profile our container and generate policies. These events help us create and help us understand what's happening inside our application, hence helping us profile them and finally creating the rules. These rules are in the form of policy.
Help understand what's happening. I love it. And so help understand what's happening in the system. And what was the next thing?
help you create policies to set up alerts and prevention.
So these 4 types of events are basically a way to do monitoring that lends itself to alerting and prevention.
Exactly.
Cool.
So the policies here are, so like you can, so KubeArmor, like the policies here are Kubernetes resources. So like you can declaratively manage all these policies, which will help you set up the alerting and prevention.
Wait, I have a question, but also we
Sure.
have some questions in chat. So Fieldstone was asking, can it detect abnormal network behavior? For example, too high of traffic compared to normal behavior.
Like how I explained, like what happens, what's the story here is that you receive these events, you have you have done the profiling, so now you have a set of rules. You say that, okay, anything outside of this happens, we know that it's an abnormality, and maybe
So
you can,
you're
we
receiving network events, and if too many of them happen and within a certain period of time, you can
yes,
configure an alert
you can
on that.
configure alerts. Yes.
Okay. So then, yes, it sounds like the answer is Fuel Snobble. And then my question is, so you just said that you create policies and the policies are Kubernetes resources. My question is, I thought KubeArmor is not limited to Kubernetes.
Okay, so like essentially you have YAML files, right? Like
Uh-huh.
it can you can either use Kubernetes custom resources to help you manage that, or you send the YAML file directly to KubeArmor over the network.
Okay.
So
So the policy, okay, I follow. So
there's a policy file
KubeArmor,
which is YAML, which is a YAML file where you define all
uh-huh.
the rules and things like that, and that can be declaratively managed using Kubernetes, or you can send them over the network to KubeArmor on your own. We have a helper utility called KArmor, which can help you do that. But yes, under the hood, you just transport that file to network, or KubeArmor watches for policies under Kubernetes custom resources.
KubeArmor policies are defined as YAML files, and then the YAML files can be Kubernetes or Kubernetes custom resources. Yeah.
Right, exactly.
Do I want to write that down here, or do I want to say more about like what that enables with Kubernetes?
No, I think it should be fine.
Yeah. So when I write a KubeArmor policy, do I write an associated controller, or does KubeArmor know how? Like this KubeArmor policy, that's a custom resource. That's a custom resource that I made when I made a policy. Is that correct?
Let's say like there's a custom resource object called KubeArmor security policies, and you
Okay, got it.
create a particular
So my
resource.
instance. Okay, so I make an instance of a KubeArmor policy. And what's it called?
KubeArmor security policy, KSP.
If I was okay, KubeArmor security. So basically, I see what you're doing here. You're mirroring this, or isn't there? Got it.
goal was that like how each and like most of the tooling out there have their own DSL, like the domain specific language to create rules and policies. But yeah, you use YAMLs for everything in cloud, right?
Yeah.
So it's
Yeah.
easier to declaratively manage KubeArmor securities and the security rules in YAML form. And that's where this helps out, declaratively managing your policies. We like declarative things instead of.
Yes. Yeah, we do. Heck yeah.
So what happens is like when you are receiving this event, so like as I mentioned, like help you create policies, right? Help to create
Hmm.
policies to set up alerting and prevention. So there are a few ways to go about it here. On a high level, like you can so you have a predefined set of rules. Like we have called something called recommended policies. So
Hmm.
what they help us is like, okay, there's an industry standard out there that okay,
Hmm.
uh, how should we say it? Like there are certificate you store certificates in your containers which help you access like to you store tokens in your containers, right, which help you access and authenticate your workloads.
Uh-huh.
So in general these are stored in a file path called etc. So the recommended policy could be block access to, okay, let me provide you with a better example. So like you ship your container and generally let's say you have an alpine based containers and you
Uh-huh.
install packages into your container using apk add, right?
Uh-huh.
But this apk add should never run in production environment because you already have shipped everything as part of container, right? But
Yeah.
if but folks generally do not go through the process of removing apk in the
Uh,
production container.
uh, okay.
So the recommended policy could be that please deny any package management and executions like
Uh-huh.
APK, apt, or any other yum. There are a lot of package management tools out there. So this is like you deny the execution of this altogether, and that could be a recommended policy.
Mm.
So now, as soon as you apply this rule, you KubeArmor would start enforcing this, and you won't have like this will not be able to execute in your containers. Or
Smart. So as a cluster admin, this already exists. I just have to take it and apply it. Well, I might have to.
yes,
Yeah, yeah.
mhm,
Okay. Cool.
you like we have this flow where like you type in KRMA, you receive the recommendations somehow, and you can just then go ahead and apply kubectl apply, and yes, they are being enforced there.
Cool.
Or but what's more important is you, as I said, you for the runtime and security aspect, you need to understand what all is happening in your container and
Mm-hmm.
create policies, manually create policies around it.
Mm-hmm.
For example, like how said service account token, let's consider the service account token again.
Mm-hmm.
I create a rule saying I want to deny service account token in general, but only allow my said application, only allow application app one to access service account token.
Mm-hmm.
So like I specify the, like I said, there are four types of events, like process, file, network. For processes, I only allow execution of app. Let's call it app only, app.
Mm-hmm.
And for file, I say that only access service account token to be accessed by app. So I have
Mm-hmm.
that granular rule that service account token file should only be accessible by app and denied
Mm-hmm.
to everyone else.
Mm-hmm.
And for network as well, similarly, only app should be able to access network events. So like
Mm.
I create these three rules, and I have a policy for saying that okay, now service account token is secure. Service account token are why I chose the service account token in general is that once any attacker has infiltrated in your system, service account
Yeah.
token is the first thing he will try to find out and try to exploit, because if
Yeah.
he gets access to service account token in somehow,
Uh-huh.
and
Or she.
by any chance it has cluster admin privileges, you have your entire infrastructure handed over to that. So that's why I
Yeah.
chose to use the service account token example.
Would you like me to write down this example policy on the board? Or do you want to save this room for other information?
We have other information, like I think
Okay.
we already covered this in the runtime security aspect, that
Okay.
how
We're just
you
adding
configure.
some extra color to it by adding what events would be used when making this. Yeah.
Like what I said in runtime security is essentially now converted to a YAML rule. Like okay, I saw this, I created a YAML file, now it's being enforced, and now you can prevent it using KubeArmor.
Mm-hmm.
What we can dive into is how KubeArmor does this, like getting to the lower levels, or do you want to, like, should we talk about something else before we get deeper into that?
Oh, this is your story. What do you think is important to share about KubeArmor?
I think so. Like, I could cover a few other. I could talk about a few other use cases in general, like how I covered
Mm-hmm.
service account token one. Other could be that how you need to have file integrity monitoring as well. So essentially, what the story here is that you try to identify what are the important aspects of your system. It would be something like, I have you heard of Vault? Vault is a
Vault.
secrets
HashiCorp.
managed HashiCorp
Vault.
Vault.
Yes.
Yes.
Mm-hmm.
So it essentially helps you manage secrets for in your Kubernetes cluster. What it under the hood does is it has everything stored in a directory called /vault/. And even though it's encrypted, like if I
Mm-hmm.
execute into the container somehow and try to access the file, it's encrypted. And people may say
Mm-hmm.
that, okay, it's already encrypted. Why do I need to have security around it?
Yeah.
Because if no one has the secure like passphrase to it, they cannot open the file or read the file. But what
Yeah.
if they add another layer of encryption on it? Now you are also not able to access it.
Ah. Yeah. Yeah. Uh-huh.
That's how ransomware attacks work. They don't need to access it. They create another security layer
Ah.
around it, and now you are not able to access it. So they play a Uno reverse on you, and
Yeah.
you don't know how to get out of that.
Uh-huh.
So that's why it's essential that you have these policies that okay, vault should only be accessible to the vault binary itself, no other thing.
Yeah.
And that's an example use case for KubeArmor.
That's cool. I'm gonna say hi to Cardis real quick. Hello, Cardis. I made a Kafka video for IBM way back in the day. I work at VMware now, but thanks for coming to say hi. All right.
So I think since we can dive into how KubeArmor works under the hood.
Sounds fun.
So essentially what happens is like how I described this four types of events, right? So
Mm-hmm.
these events happen so let's think of it this way. So we have user space where everything happens, and then since as Fuel Schnabel said, everything, we are running Kubernetes on Linux. So inside the Linux, essentially everything you do triggers a kernel event.
Mm-hmm.
And that's so like what happens is like you have a user space event. It goes
Mm-hmm.
inside the kernel, does a few things, then kernel returns back, and the entire cycle is completed. The issue in general is that like there are a lot of ways to hook onto any point between user space and kernel space communication and
Mm-hmm.
help secure things. But there are flaws around. So like if you try to secure a user space, somehow what if the attacker is already inside the kernel or something like that? So
Mm-hmm.
that's why what KubeArmor does is it directly hooks inside the kernel and decodes this event inside the kernel and helps you
Mm-hmm.
secure, like helps you with alerting like all the three things inside the from inside the kernel itself.
Inside the Linux kernel?
Yes, Linux kernel. Yep. Kubar. So
And
KubeArmor.
and that's where it sees the running processes.
Exactly. Not only sees but has the decision making capabilities to deny it as well.
It what's the word then? Where it's where it
Protects. That's where it protects your.
that's where it enforces policy. How about that?
Enforces policies. Yeah, perfect. You could say monitors and enforces policy because
Yeah,
both
I
of them
love
are.
it. What good teamwork. And we have a comment from Fuel Snobble.
Now I start to think about ways how an attacker could not go through the kernel. And there's
Yes.
only so much you like. You could keep thinking about it, and security is never enough. You will always find some way or other to start securing things.
How does something like this compare to like a higher level policy engine like I just talked about Kyverno and OPA Gatekeeper last week?
So what they so like maybe Rego is like a policy language, right? So like maybe
Mm-hmm.
you can create KubeArmor policies in Rego. And
Mm-hmm.
am I still audible to you?
Yes.
And you might not be able to see me,
Yeah. But we
but
can hear
okay.
you.
Yeah,
Yeah.
I think it will take a couple of minutes. My electricity fluctuating. But yes,
That's
if you can
okay.
hear me, that's fine
I
then.
can hear you. Yes. So you could write
So
KubeArmor policies as part of Kyverno or as part of Rego, as part of OPA.
yes, so like what happens is like we recently announced an integration with Kaiwano as well. Like what you can do. So what what they do is they work at the mutation and validation layer. What happens
Mm-hmm.
before your objects are applied into the before your objects start running. That's where it.
Yes.
And where KubeArmor comes into the picture is what happens after
Uh-huh.
the object starts running. You get
What
visibility
happens?
into
What happens after what?
your application starts running.
Okay.
It's
Okay.
actually working, right? Like
Ah, yeah.
Kaiwano and OPA work before
Mm-hmm.
admitting things.
Mm-hmm.
So that's how it works. Like you can have a Kaiwano policy saying do not allow auto mounting service account token, or let you know that okay, this application is being mounted by this application is mounting service account tokens. But
Mm-hmm.
you cannot say that okay, inside your application go ahead and say like only apps should be allowed access to service account token. It does not have the runtime view. That's what I'm trying to say. We do
Mm-hmm.
integrate with we recently announced an integration. KubeArmor and KubeArmor did integrate, and hey, I'm back.
Hey, you're back. So ideally, you want both, or
Yes,
do
you
you?
want both. Yes,
Okay.
and that's what
Yeah.
I was trying to talk about. Like you can use your visibility into runtime to help create
Mm-hmm.
your those policies as well. Like, okay, there are applications out there which never use service account tokens, but
Mm-hmm.
Kubernetes generally auto mount service account token. So like you now can set up a policy saying, please do not auto mount service account token. Only these and these apps should be allowed to mount service account token.
Okay.
And that KubeArmor visibility helps you gain that information that, okay, who all are accessing service account token, and have the, how do you say it, the policy to prevent that.
We have a comment from Fuel Snubble. A friend of mine, of Fuel Snubbles, is in fintech and uses specialized network card that don't go through the kernel. It's too slow. In that environment, I think an attacker could cause his program to explode without a kernel.
It's like, yes, like that does happen. And I'm not, I think we will dive deeper into how KubeArmor works today. And there's a technology called eBPF, and
Uh-huh.
it helps you with setting up how you can like even with specialized networks card and go through the kernel and help without, you can secure it that way as well. And there are
Mm-hmm.
tools out there which do that.
All right.
Cool. So
Uh,
we covered, okay,
uh,
we started talking about Trevor.
I I gotta shut this down. It's flipped in the camera. I'm writing facing me. I'm not writing in reverse. I gotta, yeah. I'm a great person and talented in a lot of ways, but writing in reverse is not one of the ways. Okay, sorry, I just
I
had to say.
I thought that was supposed to be a secret. It was magic witchcraft happening, and you could write in reverse. We never know.
Yeah, I have no secrets. I expose all of my vulnerabilities.
Yes. So, yep, we could continue about how KubeArmor works under the hood.
Sure.
So, KubeArmor doesn't really. So, in security, there's a thing that you should never invent new thing, like a new way to start securing things. And KubeArmor continued to do that. What it did was it leveraged what's out there already. So Linux already had a mature ecosystem to help set up this security
Mm-hmm.
enforcement and policy thing, and it was called Linux Security Modules.
Okay.
So LSMs in short. So under the hood, KubeArmor uses LSMs to help you.
Sorry. Linux security model.
Security modules.
Module. Oh, it wasn't even correct. That's okay. Module. Singular or plural?
Plural. We have a lot of modules.
Okay. Cool.
LSMs.
See.
Okay. So to help you with providing inline enforcement, to help facilitate inline enforcement.
to help facilitate it. So what inline enforcement, we mean it happens at the moment.
Yes.
I'm listening. You can keep talking.
So that's how KubeArmor helps with enforcement. But the issue is that these Linux security modules have their own languages. So there are two issues. So you can ask that why should I not use LSMs directly? Why should I go through KubeArmor to help me with starting enforcement? But what happens is LSMs have their own like the DSL, like they have their own language to help with rules. The first problem is that you need to go and learn it,
Uh-huh.
and they are not really easy to understand that way.
Uh-huh.
And the second problem is that they don't have the context of containers. They were made for Linux, and they accept rules in the form of like what process was executed. And so there's a lot of kernel data involved, and
Mm-hmm.
you don't have it abstracted away at container or Kubernetes object level. So KubeArmor like abstracts away that complexity and adds the context that okay, suppose like I mentioned, app was executed, but app was executed. So what Linux security module knows is maybe app was executed in PID, ID, mount ID, and there's a lot of numbers involved in that. But what KubeArmor would tell you is that okay, the app was executed in container one, which is part of pod one, which runs in namespace XYZ in your cluster XYZ. So you have all the information about okay, I now know that this app executed at this point, it at this specific container, and help me identify that. So you have all that context. And on the same time, for the enforcement side of things, you don't need to go ahead and mount onto each and every container, find the container, how to apply LSM policy to it. What you can just simply do is we have YAMLs, we have a declarative way to manage that. We can just specify labels like okay, apps, maybe my app WordPress needs to be protected. So I
Uh-huh.
add the label to my policy that please add this set of rules to app my WordPress application, and that's how we can start securing things. So KubeArmor abstracts away. So like as I mentioned, so I mentioned earlier pod security context, right? So security context does accept AppArmor profiles or SC. So example of LSMs are AppArmor, SC Linux, and BPF LSM, and we can add that. So pod security context does accept a specific rule, but you still need to manage around how to load that rule to the kernel, how to load that rule to the kernel, and how to have the like as I said, you don't have the context like where it would be happening. You can mention in your deployment file that okay, load this particular profile to this particular container, but you now don't have the visibility now exactly where it's being denied. So that inferior alerting problem.
Um, can let me make sure I have everything correct. And I also, what are some more examples of LSM besides
uh,
AppArmor?
SE Linux.
Oh yeah, Security Enhanced Linux. I know that one.
Yes. Yes.
Okay.
And there's BPF LSM. It's pretty new, but
Okay.
we we are using it, and it is helping us enable this inline enforcement across like providers now.
Okay. So KubeArmor uses Linux security modules, LSMs, to help facilitate inline enforcement. Some examples of LSMs are AppArmor and SE Linux. But KubeArmor improves upon LSM because it adds the context of the container to the LSM. KubeArmor uses YAML, so you don't have to learn a new language to use an LSM. And KubeArmor can also use existing CLM rules.
Yes, LSM rules.
That,
Like you can add native rules to KubeArmor directly. So I wanted to talk about like what another problem with LSMs is that maybe so like we talked about AppArmor and SC Linux, right? So
uh-huh,
SC Linux is generally available on Red Hat based distributions.
uh-huh,
Like
uh,
like the node images are Red Hat based, but and AppArmor is generally available on node images which are Debian based, like Ubuntu and things like that.
okay.
So you have this disparity that okay, what if I have a cluster having one Debian node, one Red Hat node?
Mm-hmm.
So you need to now manage rules and create rules for both of them and manage them.
Yeah,
But KubeArmor can convert them both to both of them and help you enforce things.
that makes a lot of sense. So do you want me to capture that on the board? And if so, what's the need? Let me think. Yeah, KubeArmor can integrate LSM rules from different Linux OSs. I don't know if simultaneously. Cool. I want to address a comment simultaneously. Doso. So says, please tell me your whiteboard marker is connected to an app that tracks your motion and creates a digital version of this that can be shared online. So it's actually way simpler than that. At the end, when this is over, I'll just take a picture of the board and I'll post it onto Twitter. So if you follow me on Twitter, so there's no magic marker. This is just a regular neon dry erase marker. But if you follow me on Twitter, I have a whole thread. Let me put your comment away. I have a whole thread. There it is. And you can follow Barun while you're at it too. I have a whole thread of finished light boards from these shows. And so tomorrow, probably I'll add a photo of this to that thread. If you follow me on Twitter, you can snag it at that time. But again, sorry to disappoint you yet again, Doso. There's no magic involved. Not a witch. Although if I'm in denial too much, it definitely makes it seem like I am one, right? All right. Life is magic. It's true. This digital day and age is magic. The fact that you're like in Norway and you can just send me a message that I see in real time is magic. No one needs to be a witch. Everyone's a witch. Yeah.
A
Okay.
lot of witchcraft happening as we speak. As
Exactly. All right.
back to like okay, so I did mention like KubeArmor directly hooks inside Linux kernel. One
Uh-huh.
thing was so like one thing was that like we do use Linux primitives, which help us with that. But the reason why we want to hook into the kernel itself is that it's performant. Like you shouldn't be have you should not have too much. So like if you try to think about, we are doing so many things, right?
Mm-hmm.
We are live capturing what is happening. We do a decision that okay, whether this should be allowed or not, and it can add overhead to our, and this is happening for each and every event inside kernel, which could be at scale of like if you have a huge workload, it could be maybe thousands or millions of events, tens of thousands of events per second, which is huge. And having that decision making for each and every event can be can affect your performance. But when we hook directly into the kernel, because the data information is so readily available, it induces a lot less overhead. We recently benchmarked in a specific way, and the overhead was less than 3%. I would not try to call out that okay, we achieve security in less than 3% overhead, but that was a specific case that we tried out, and it was such that the overhead was pretty less, and that is only due to the fact that we are doing this inside the kernel. Because as soon as if you move this decision making to user space, what happens is it goes through the entire kernel life cycle, comes back to user space, and then you go ahead and deny it, and then it again goes back to the kernel, goes ahead and denies it. So essentially you increase a lot of cycles, which can affect performance. But the way we do the way KubeArmor does it, helps with the performance aspect as well.
Cool. Yeah, I hadn't thought about that, but now that you mention it, if every single if events are being emitted for every time any of these things happens, that's a lot of events. And Fuel Stumble has a comment. You shine a light on a rock in space for some time, and this leads to a stream about KubeArmor. Didn't see that one coming. Yeah, it is magic. Life is magic. Everything's magic. What a funny moment.
What next? Okay, so I talked about LSMs, right? As I mentioned, KubeArmor does monitoring and enforcement. So monitoring your system and enforcing things. So LSMs help us with the enforcement aspect of it.
Okay.
As I said, these don't have LSMs on their own, do have their own auditing mechanism. Some use audit D, some have some use kernel daemon itself. There are tools out there, but we won't have the flexibility to attach the context if we try to use that. And as I already said, we need to stay performant as well. So if we rely on the events emitted by LSMs, what it would be that okay, it was denied in the kernel, but then the event comes back to user space. KubeArmor would capture it in the user space, try to add context to it, and there would be a lot of delay there. So for monitoring as well, we use a kernel technology called eBPF.
Okay.
And that helps us with monitoring kernel events and provide you with real-time observability data, which can help you provide visibility, observe all the behavior that you want to know is provided with the help of eBPF.
And the eBPF, repeat please what problem it's solving?
What it's solving is that we have a performant way to hook inside the kernel and capture all the events that I mentioned earlier.
Okay.
And because it's inside the kernel, we need to be careful and safely access things as well. And eBPF and LSM, both of them have a safe way to help us enable that. So we are not doing anything which could cause irregularities in your system.
Cool. We're mostly out of space. I could probably fit a fun fact here. maybe like one little sentence down here, but we're doing it, Varun. We're almost there. This is great. This has been really wonderful. You're doing a great job.
Yes, like I like you. This is pretty well as well. Like how we have covered individual points. I could never thought. I never thought that I could speak for so long about so many things. Because
Me either,
generally
honestly.
sessions out there are 20 to 30 minutes,
Uh-huh.
and here I am speaking already for over 1.5 hours. So this is nice.
It is. And I used to be a really, really shy person, believe it or not. So I kind of can't believe that I speak so much in public. That this would be my career. I could have never guessed. I think you just froze. We just lost you. Well, I'm going to talk on my own a bit. I'm thinking a little bit about what to put in this space. I feel like I want like a takeaway. Maybe it'll come to me when I do the recap. If anyone's there, hopefully it's not me that's the problem. It's not. I have a few streams going. If you have any questions for Varun when he comes back, please add those now because I'm going to start the recap soon. And once that recap's over, we're going to dance it out and it'll be over. I forgot to tell Varun about the dancing at the end. He said he's watched episodes, but what's common is guests will say that they've seen episodes before, but they've never watched it to the bitter end, so they don't realize that the dancing part is coming. So, we lost him completely. That's okay. We'll see if he comes back. I think I'm just going to start. I don't really want to start a recap without him because I love having his. Oh, he's coming back. I see him. Input on what's happening in case on the stream. There we are. Hello again.
Hey, really sorry. I'm not sure what
Nah,
happened.
it's fine. I was just talking to just the stream and just saying I think I'll maybe when I do the recap what like one big takeaway to put I'll add it here. But is there anything you think that should be either here or anything else you want to say before I start the recap?
I think we let me check once. I did prepare a set of notes, but I think we covered it all.
Amazing. This is
So we already talked about how we can have application behavior. One thing could be that what I say about like how we need to profile things and create a rule based on that. So the term we generally use is the policy of least privilege rules, least privilege accesses. So we
uh-huh.
need to and in like industry famous word is generally called zero trust. So like you
Uh-huh.
set up zero trust rules and least privilege rules. So like the philosophy here is that you don't want to trust what all which entity inside your container has access to what all other entities. So you set up a
Mm-hmm.
least privileged rule set saying this application should only be able to access these rules, these set of
Mm-hmm.
entities, and that's how we try to contain and tackle unknown things, unknown vulnerabilities.
Use KubeArmor to set up least privilege policies.
Yeah,
Least
least
privilege,
privileged access.
LEA. Least privilege.
Big word to prepare.
PRILEDGE. Least privilege access rules. Zero trust. What if you moved through life with zero trust? That would be I think, a sad existence. Okay.
I yes, like essentially, like, there's a concept in web, like we call it web of trust, because like how we are trusting out there each other, communicating things, and then
Yeah.
here's the industry trying to push zero trust. It's kind of
Yeah.
ironic.
Yeah, trust is connection between humans, at least, or between
Mm.
ones that talk to each other. Okay, are you ready for a recap? I'm going to recap. If I say something wrong, I'll check in with you at the end. But if I say something wrong, feel free to interrupt me in the moment too. But way back, 1 hour and 40 minutes ago, we talked about, I knew nothing. And so we have to start with even what is runtime security so that we can begin to talk about KubeArmor. So we talked about, to give runtime security that concept some context, we talked about scanning container images for vulnerabilities, which is a pretty common thing to do in our industry. But those scans only account for vulnerabilities that are known. And so there are lots of security issues that you can't scan for. So for example, unknown vulnerabilities, or at runtime, if there's an attacker already in the container, that sort of someone taking advantage of that, the scan only happens before when it's a container image. So basically, there are a lot of unknown unknowns at runtime, and that we need to secure against. And that is the problem of securing runtime security. So securing runtime, period. Yeah. So runtime security includes 3 things. So monitoring, alerting, and preventing. So then we dug into that and kind of talked about an example to help us illustrate the point. So we have how to define and implement. I think we maybe lost Barun again. Are you there, Barun? I think he's gone. But I'm just going to talk through this anyway. And then maybe he can watch it in the recording and give us feedback. So we talked about how to define and implement runtime security in your system. So the first step is to profile your application. So when you have your application in like a dev or a staging environment, then you need to be observing it. So for example, if we're watching an app that accesses the Kube API with a service account token, so that's what we expect the app to do. So the steps of what's happening here is, number 1, the app is executed, the app is running. Number 2, the app accesses the SA token. And number 3, the app talks with the Kube API. Maybe vice versa, but those are 3 things that are happening. And so that's what we're monitoring. And then now that we have observed our application, now we can create a policy around it. So then the application moves to, hello again. I just talked about step 1 of, I'm still talking through this. You can watch the recording later, and if something's wrong, we'll try to tell, but I'm pretty sure. So I just did step 1 of implementing runtime security in your system. So then the app's going into production, and we expect this behavior that we have defined here, this execution of app, and the app will talk to Kube API, and the app will access the service account token. So we're able to create policy around that. So then if we have another app in the system try to access this service account token, we've created a policy, and then something will happen. So that's where step 3 comes in. So we have alerting. So one strategy is asynchronous enforcement. So when that unknown app tries to access the service account token, the attack is, an alert happens, and the attack is prevented at that time. So the problem with that is the prevention doesn't happen until after the alert. So the attacker does have a few moments there before they're caught to maybe get at that token. So what you really want is the second strategy, which is inline enforcement, where the attack fails before it ever happens. So the prevention happens alongside the alert. So that is runtime security, like what it looks like actually implemented in a system. And then we got to KubeArmor. So KubeArmor is a cloud-native runtime security engine that helps you handle monitoring your system, alerting on anomalies, and preventing security issues. And so KubeArmor is not limited to Kubernetes, so it's also good for edge workloads, for example. And then with KubeArmor, you define your policies as YAML files, so they're declarative in their YAML. And they are good for Kubernetes too. The KubeArmor policies are also Kubernetes custom resources called a KubeArmor security policy. But really, at the heart of these policies are KubeArmor events. So KubeArmor emits 4 types of events. One is a process event, so that would be like the execution of an application. A second is a file event, so if an app is accessing a particular file. The third one is a network event, so an app tries to access a particular thing over the network, for example, the Kube API server. And then a system event, so if an app ever tries to make a system call. So these are things that you can you can be monitoring and you can use to help you define what you want your expected behavior to be that's wrapped up in a KubeArmor policy. So I guess that's what I wrote here. KubeArmor uses these events to help you understand what's happening in the system and to help to create policies to set up alerting and prevention. So KubeArmor is good with Kubernetes, but it doesn't have to be Kubernetes. And so KubeArmor, one cool thing is, and I love this about open source in general, KubeArmor can supply recommended policies based on industry standards. So for example, a great policy for pretty much everyone would be to deny any package manager execution in production, because you should already have your stuff wrapped up in your image by then. But that's just one example. And then these recommended policies, do you have like a place for a community to share policies?
Yes. So like we have this repo called policy templates where we have a curated set of lists, but people can add it there as well. And mostly like it's categorized under various frameworks out there like MITRE, CIS, NSA. So they have guidelines out there, and these policies are based on that. Or anyone can just help us add there as well. I'll share the repo with you. You can push it.
Yeah, if you share it in the private chat, I'll put it in the... And
we are currently trying to integrate with I think it will take some time, but if we are integrating with Artifact Hub, it's a CNCF project. So basically we can store these policies as part of OCI registries.
Cool.
And so you will have this entire workflow of signing and verifying whether the policy is valid or is by a trusted user or not. But today we do it through a GitHub repository. But we have that in the pipeline, and someone is working towards that.
So one cool thing you can do with KubeArmor is to set least privilege access rules. So we talked about zero trust. So as soon as that link comes in, I'll share it. But meanwhile, I'm going to keep going with the recap. So we talked about how KubeArmor works and got in a little bit to like Linux kernel functionality stuff, which is relatively new to me. So I'm pretty excited about it. So KubeArmor directly hooks inside of the Linux kernel, and that's where it monitors and enforces the policy. So that's different from policy stuff that we've talked about before, where last week we talked with Open Policy Agent, and we talked with Peter, who did Open Policy Agent, and Chip, who taught us about Kyverno. And so those are different. Those policies are happening at the admission layer. And so KubeArmor is different because those policies are happening at runtime as part of kernel monitoring. Let me get this link in the chat. Bam. And so, yeah, so those different, that was something I needed to clear up in my head, and we did. That was great. So I learned about a thing called Linux security modules, which I didn't know about before. KubeArmor uses LSMs, or Linux security modules, to help facilitate inline enforcement. And inline enforcement is what we talked about when the attack is prevented before anything actually happens. instead of immediately after something happens. So some examples of LSMs are AquaMonitor or Security Enhanced Linux. So KubeArmor improves upon LSMs, though, by adding the context of the container to the LSM. Also, you can use YAML with KubeArmor. If you use LSMs directly, you have to know about the language of the LSM. KubeArmor can use those LSM rules directly and integrate those. And then KubeArmor can also use the LSM rules from different Linux operating systems simultaneously. So when we talk about AquaMonitor, you said that's specific to what distribution of Linux?
Debian based.
Debian based, yeah.
Ubuntu could be like more widespread, so you can say Ubuntu.
Okay, Ubuntu or Debian based, and SE Linux is like a Red Hat based LSM. So if you need rules from each of those different LSMs, that could be hard to integrate in your system. But with KubeArmor, that makes it easier at least, right? And then KubeArmor is performance partly because it hooks inside of the Linux kernel. So if you think about all these types of events happening for every application that's happening in your system, that can be a very, very large number of events. But KubeArmor is able to do that since it's operating at the Linux kernel level and not the user space level. And then also it's helpful because it's using eBPF to help with monitoring. So eBPF is a way to sandbox the Linux kernel, right? So, oh, Nick, the first one's here. Hello, Nick. You're catching the tail end of the recap. But thanks so much for coming. So eBPF is basically helps KubeArmor look inside the Linux kernel and capture events in the performant way. So eBPF's at the core of that. And eBPF helps to safely access the kernel. Because back before eBPF, accessing the kernel was a dangerous thing to do. And now it's a safe thing to do. It's opening up a lot of doors.
Exactly. You would need to modify kernels and things like that had to happen. But now there's a specific sandbox, as you said, sandbox environment inside Linux kernel where you can run your own code and safely and performantly access things. So safe and performant is the key.
Yeah. Yeah, so that's KubeArmor and how you can use it to define and implement runtime security policies in your system. I'm convinced. It's great. Good job, Varun. I really, really appreciate you and sharing your time and expertise. I'm gonna say thanks. Nick was in back-to-back meetings. It's okay, Nick. We know you would be here if you could. So the way we close out the show, I don't know if you've ever watched One to the Bitter Ends, but the way we close out this show is by dancing our goodbyes. So I'm going to play the intro music again, and we're just going to dance a little bit and say goodbye. Is there anything else you'd like to say before we go?
Sure. Please join KubeArmor. Since KubeArmor is an open source project, we are active on Slack. So please join us on Slack. Chat there, ask your questions. If you have any questions, do shoot them there. Join our community. We do have community calls every 2 weeks, so you could just join them and ask questions there as well.
The KubeArmor community has their own Slack workspace. So a lot of technologies we talk to have a channel in the CNCF Slack workspace, but KubeArmor has their own Slack workspace to check out.
We do have a channel in CNCF. You could just ping us there. I will post a link to Slack maybe on our own. We are active on our own Slack only, but yes, we do have a channel, but most of the activity happens on our own channel Slack.
Okay, and that's great. So so you can get a hold of everyone there. We have a nice Fuel Snobble is excited for the dancing. I think Fuel Snobble. Kumar says, thanks, Varun and Whitney, for the session. Thanks so much, Kumar, for being here. I appreciate you. And then Nick says, thank you for helping me and my friend with our Kubernetes questions. Oh, yeah, of course. I'm glad that worked out for you. You can DM me more about it later. But thank you. And everyone, have a wonderful day. And I'll see you next week. Bye. Yeah, Varun, you got this. Heck yeah.